Okay, so now all we have to do is take these points and plot them on the grid. Now I don't know if we're going to get down to negative 30, so maybe we might have to count by twos. I'll take a quick look here and see if that is the case. Okay, so here we have negative 30, and the first point we have is negative 7, negative 30. So we'll go to negative 7, 2, 4, 6, 7, negative 7, and negative 30. That's the first point here. And we're going to have 9 and negative 30. So there's 9 and negative 30. It's right here. And then we've got negative 3 and 0. And we've got 5, 0. And then we've got 1 and 2. Okay, so it's a quartic function. And if you know anything about quartic functions, or if you recall from previous lessons, quartic function generally is a little flatter, but in this case, because of the vertical stretch, it's a little bit less flat along the base near the vertex, and it's a little bit more curved like a parabola, and then this would be the final transformation of that quartic. Okay, welcome to part 3 of transform functions, or graphing functions with transformations. Again, let's take a look at, now this is a different type of function, of course, and we'll take a look at the transformations, and we'll go along here from left to right. So we see there's nothing out front of the cosine here, no value in between the cosine and the bracket. So we just go inside here, now it's a horizontal translation, which is also called a phase shift when we're dealing with sinusoidal functions. So we'll say 60 degrees to the right. And then here we have a vertical translation. Two units down. Okay, so let's take a look here. Again, we've got the 5 main significant points of the cos function, and if you recall the cos function, when x is 0, y is what? Please complete these values here. So y is 1 when x is 0, when x is 90, y is 0, when x is 180, y is negative 1, when x is 270, y is 0, and when x is 360, y is 1 again. So now we have to use these transformations to then write the transformation statements here. So we see we've got a 60 degree phase shift to the right, so it'll just be x plus 60, and then there's a vertical translation down 2, so it'll be y minus 2. Okay, so here we've got 60 degrees, 90 plus 60 is 150 degrees, there's 240, 330 degrees, and then 420 degrees. And then we'll subtract 2 from all of these. We've got negative 1, negative 2, negative 3, negative 2, and negative 1. Okay, and then we just have to figure out how we can label this x-axis in order for all these values to appear on the axis here. Okay, so take a couple seconds and find or count how many there are and see if you would be counting by 30s on each grid, or count by 60s or 15s or whatever it may be, in order to get a nice good graph that will use up as much of the grid as possible. Okay, pause now please. Okay, so I've decided to mark 60 degrees every 3 grid marks. Okay, so that should give us a nice big graph there. And so then we just have to plot the points. So I got 60 and -1, which is a point right here. 150 and -2. That's going to be halfway between 120 and 180. Then we've got 240 and -3. Then 330 and -2 again here. And then 420 and -1. And then from here, draw a nice smooth curve. Okay, please don't make the curve jagged lines. Make sure that it's a nice smooth curve. Okay, so that would be the transform function given by that. Okay, moving on to the next one. Now, one thing you have to be aware of is with these types, if we have a coefficient of theta, you have to make sure that you factor it out of this to get the appropriate phase shift. Okay, so this is going to be okay, so then I'll just write this down here. And then we can go through this and write down the transformations. So pause the video please to write down the transformations. So we have a transformation or a reflection of the x-axis, vertical compression by half. Then inside here we've got a horizontal compression by half. And then we've got a phase shift, because that's always horizontal, phase shift 45 degrees to the right. And then a vertical translation up 3 units. Okay, and then we'll work on the same values that we did before. Use these x values to get the values for sine. So when x is 0, y is 0. When x is 90, y is 1, 0, -1, and 0 again for sine. And then we need to work on the horizontal transformations. So that's going to be a horizontal compression, so that means that we're going to be taking all the x values and dividing by 2, all the theta values, and then we're going to be adding 45 degrees to those. And then for the y values, we're going to be multiplying them all by -1, then by a half, and then adding 3. Okay, so pause the video please and make all those calculations. And then we just have to work on these ones. 3, -1/2 plus 3 would be 2.5 or 5/2. Again 3, And then we've got 3.5 or 7/2, and then 3 again. Okay, and then now the tricky part, we need to do the grid or the scale along the theta and the y-axis. Okay, work on that please, and then we'll come back and check the graphing of this transformed function. Okay, so we'll label this 45 degrees for every 4 squares here, and that should space it out nicely. Okay, and then we can just go ahead and plot the points. So 45 degrees and 3, then 90 degrees and 5/2, 135 degrees and 3, 180 and 7/2, and then 225 and 3. Okay, and then we'll just, the best we can, draw a nice smooth curve here. And that would be the graph of that function. Okay, so here's the work. Please work on the first 3 or 4 at home, and then work on the rest tomorrow in class.